Okay, I think that we may slowly start. So, generally, hello everyone. Today's webinar will be composed of the two parts, the main related to use case and then Q&A session for our guests. Of course, please be noted that recording and the slides will be shared with all participants by email shortly after the webinar. And as I mentioned, we will have the Q&A session. Therefore, if you have any questions or thoughts, just please put them on the chat, and later on we will address hopefully all of them. So here is agenda of our today's meeting. At the beginning, maybe speaker's introduction. So as I'm right now talking to you, Łukasz Kubala, head of business unit at MakoLab, driving digital innovation projects and business growth for leading automotive, finance, and insurance organizations. Many years of working with enterprise clients, including major car manufacturers, captive banks, and insurance providers. I'm focused on building long-term partnership with customers. Thank you. And Kundan?
Hi, Łukasz. Hi, good evening and good morning to some of the folks who are joining from other parts of the world. I'm Kundan Vyas. I'm part of the product team here at StreamNative. I also lead the partnership strategy as well. So I'm looking forward to this session to speaking to you all.
Rafał?
Hello, everyone. My name is Rafał Trójczak. I am a senior backend developer, specializing mostly in semantic web technologies and also in big data technologies. Thank you.
Okay, so let's start in fact the content of the webinar. Once more, if you have any questions or thoughts, please just publish them on the chat, and we will address them later on during the Q&A session. So let's start with a quick story. Imagine one of the leading automotive brands in Europe, a company operating across many markets, but delivering hundreds of thousands of cars to the customers every single year. But what's really interesting is the transformation that they are going through. It is not just about building the cars anymore. It is about building software, enabling new mobility models, and connecting vehicles into the single digital ecosystem. And that's why where our story exactly begins. So let's take a quick look what the customer ecosystem really looks like. It all starts in the factory, or in fact, couple of factories, where each vehicle begins its life and starts the digital history. Then logistics comes. Thousands of vehicles moving across Europe, tracked by ships, trucks, digital systems, all generating more information. Once the cars reach dealers and hubs in different countries, new layer of data appear. Additional accessories, inspections, customer profiles, financing, delivery, etc. And then during the use and maintenance phase, millions of vehicles on the road are constantly producing streams of connected and service data. And finally, when cars reach the end of their life, data still remains, closing the loop of this vast and data-driven ecosystem. As we move through the vehicle life cycle, different types of data are being created at every single stage, from the very first VIN number generated in the factory all the way to the vehicle's end of life. Some of the events happen only once, like production or first registration. Others repeat many times: maintenance, repairs, warranty claims. And once connected and telemetry comes into the play, the number of events grows exponentially. Every trip, every sensor reading, every status change adds to the stream. OEMs have been already collecting and processing data for years, but as the ecosystem evolves, legacy systems often struggle to keep up with the scale and complexity of modern data. That's where the real challenge and, in fact, opportunity for us begins. Let's talk about the key challenges that existed before the new architecture. There was no single unified structure and no strict data consistency rules. That made it really hard to get a full and reliable view of the vehicle history, especially for different stakeholders across manufacturing, after sales, and more. Even if the data existed, it wasn't easily accessible in the unified and standardized format for other systems to consume. While the previous setup worked fine at that time, it wasn't ready for the future volume of data, especially with the rise of connected vehicles. A customer expected a massive growth in the number of telemetry events and needed to ensure both the data is processed instantly and large volumes of events can flow without the delay. So what should the new future-ready system be able to do? First, it needs to collect data from many different sources, dozens of systems, various formats, different technologies, all coming together. Then it must handle both static and streaming data processed almost in real time. And I'm smiling because we will come back to what real time and near real time really means in a moment. Next, it should enrich raw data with context so that events become meaningful information. Rafał will also tell you more about this part. And finally, it has to ensure consistency and completeness, acting as a glue that ties everything together and guarantees data quality. Continuing with the system assumptions. First, data storage. Some data needs to be instantly accessible with very low latency, while most of it must be stored for years, sometimes even longer than entire vehicle life cycle, for example, for legal purposes. Next, the system should be able to serve data to consuming systems in different ways, as a live streams or aggregated and searchable datasets in tools like Elasticsearch. And finally, we can't forget about the observability and auditability, where the data come from, how it got there, who touched it, when, and what has changed. So everything I've discussed so far, all the data sources and processes, comes together here in the Vehicle Data Hub. And to handle this efficiently, our client has chosen the Pulsar and StreamNative platform. And now Kundan will tell more about this part. By the way, if you have any questions, then again, please put them on the chat and we will address them later on. Kundan, the stage is yours.
Awesome. Thank you, Łukasz. I think thanks for setting the context here, really, for the kind of challenges typical companies face as they're setting up data platforms for automobile industry or vehicle data profiles. It's absolutely true that the companies are no longer just being focused on their particular vertical, they all are becoming a software company. They all are becoming a data company and an AI company, right? So perfect. So on that note, basically continuing what Łukasz spoke about, this particular customer kind of chose to use a particular technology platform from StreamNative, purely the Apache Pulsar technology and a few other components to kind of build that platform. So let me actually walk you through and give you an introduction to StreamNative and the platform which kind of drives this whole solution, right? All right, so quick background on StreamNative itself. Like, this is a company created by the founders of Apache Pulsar. Apache Pulsar was created back in 2012 at Yahoo as a streaming and messaging technology, which was then open sourced in Apache Software Foundation, and it became a top-level project in 2018. So the company was formed in 2019, basically, to offer fully managed services for Apache Pulsar. But over time, we also started supporting Kafka compatibility, which means that underneath the infrastructure is Apache Pulsar, which is driving everything, but we also provide you the ability to access that infrastructure via Kafka protocol and Kafka clients, right? We also support MQTT. So we are mostly talking about multi-protocol capability here. So I'll walk you through those details. So anyways, this is a quick background. And finally, to end, in 2023 onwards, we've been focusing on a new technology called Ursa. It's basically our premium set of capabilities within StreamNative Cloud, which provide a lot of value around cost efficiency, right? So that's a little bit of background on StreamNative as a company and the history of the company. Now let me just move on. Let me start with the platform itself. The StreamNative One platform essentially supports both Kafka and Pulsar, which means that we support the ability for you to interact via both type of protocols and the respective clients. We support more than 200 connectors with the combination of both Kafka and Pulsar-based connectors. You can just mix and match any of those connectors to build your pipeline. If you want to write your custom producers, to write, to either read or write data in and out of StreamNative Cloud, you can use any of the client libraries based on different language runtimes, both for Pulsar or Kafka, right? Now, we also support the ability to natively write to lakehouses like Databricks, Snowflake, Amazon S3 tables. And basically, that is only possible because now we are able to interact, basically ingest data in open table formats like, Delta Lake or Iceberg. And that is really a support which is built natively within StreamNative Cloud. We also provide support for stream processing. So you'll hear a lot about that today. We provide different capabilities, but I think we particularly are going to talk about Flink, which is built right into StreamNative. We also support something called as Pulsar Functions, which is a part of Apache Pulsar. It's a very, for lightweight data processing, stream processing, you can use any of the language runtimes and write your custom logic and then deploy that. So as and when the data arrives in StreamNative Cloud, it can be processed using your custom logic. Right? That's yet another option. So that's the quick overview of the platform itself. It really supports a broad set of capabilities. And for today, I think we're going to be kind of zooming into a few specific areas. But before that, just want to also give you a visibility into the type of deployment options we support. So we support both fully managed and then self-managed options. So the serverless, dedicated, and bring your own cloud, which is called BYOC. These are all the cloud options. These are the fully managed options which you can choose. Serverless and dedicated run in StreamNative's cloud account. Bring your own cloud is a very popular option for us that runs in customer's cloud account. But we manage all these three options, fully manage the service. And private cloud is something which is for customers or organizations who want to self-manage it within their own cloud or in a data center. Right? So these are some ways in which you can deploy the StreamNative Cloud One and StreamNative One platform. Now, let me quickly cover a few specific details around our Flink offering. So essentially, StreamNative is a single platform which can bring you messaging, streaming, and AI capabilities. And particularly when it comes to stream processing, we've partnered with a company called Ververica. They are one of the creators of, basically, they are the original creators of Apache Flink. And what we've done is actually we work very closely with them because they understand Flink better than anyone else. So we partner and package their the core platform into StreamNative Cloud, and we offer that to our customers as a fully managed service, right? So with the StreamNative Cloud, you can now find a Flink service which is powered by Ververica, right? Ververica also is basically a company now acquired by Alibaba. They're a part of Alibaba. Now, the good thing about having Ververica within StreamNative is that I'll introduce you more to Ursa, which is our premium sort of capabilities in StreamNative Cloud. They provide you the ability to save costs on your infrastructure based on the type of use case you have. That combined with Vera, which is actually the premium engine of Ververica, the Flink engine, it boosts your overall performance to process your applications, right? So I think this combination is tuned really well for efficient stream processing applications. And one of the main things which really drives that is, I would say, the ability to host both Flink and your Pulsar or Kafka in the same VPC. Having that sitting data and processing sitting next to each other makes it very efficient in terms of particularly saving network costs as the data is actually arriving in StreamNative Cloud and getting processed. So I think this is definitely one of the big value props of having these two together within the same network, right? So that's a little bit about Flink within StreamNative Cloud, and you'll hear more about that from throughout the session today in terms of how that is being actually used. I'll quickly keep moving forward to kind of share some more details here. Now, coming back to StreamNative Cloud or StreamNative in general, right? I think we are focused on, all the use cases which need access to data in real time, right? Fintech or e-commerce retail, most of these use cases, they cannot really survive without having access to data in real time. So these are the use cases where definitely our platform shines. I think we are going to be talking particularly about automobile and vehicle data profiles today, but I'm just giving you a broader perspective of all the use cases we support. Just wanted to give you a perspective on the type of companies who use Apache Pulsar. This is basically, there were a lot more logos than what I could fit into this slide, but essentially Fortune 100 and Fortune 500 companies, large data teams, they rely on Apache Pulsar for a very efficient data streaming, data messaging, message queuing system. And I can share more details about these customers at the end of the call. So let me just walk you through a few more details on StreamNative. I know I spoke about the platform broadly, but I also want to talk about some of the core pillars of StreamNative and how customers use it, or what do customers use StreamNative for, right? The first thing is the proven message queue. The beauty of StreamNative Apache Pulsar is that it combines streaming and message queuing capability in the same infrastructure. So you don't have to really maintain two different infrastructures for your message queuing or streaming capability. And that message queuing capability is well adopted and well proven. And I'll share some references of customers who are using that in a mission critical type of applications on a daily basis. Then we also have support for Kafka, which then allows you to natively integrate with lakehouses like Snowflake, Databricks. So as the data arrives into StreamNative Cloud, you can configure that to stream to your favorite destination, like either Databricks or Snowflake and others. The third area is relatively new for us, but this is really where we're going to go stronger, where we recently launched a agentic AI capability within StreamNative Cloud. which allows you to kind of deploy your agents within StreamNative infrastructure, right? So I think let me walk you through some more details of that. So let's talk a little bit about message queuing very quickly. I mean, this is definitely one of the core capabilities within Apache Pulsar, but StreamNative Cloud enhances this, makes it more scalable. We cannot take the worry away from organizations to to manage this infrastructure, and we can handle that for them. Essentially, I won't go through all the features, but essentially message TTL, the cloud native aspect, the retries and backoff DLQ type of capabilities are all designed in such a way that basically you feel that you just have topics, and those topics can be used as queues or can be used as streams, or then eventually the stream can be converted to a iceberg table. So we've thought about this architecture in many different ways, and the message queuing core message queuing capabilities are something which you can very much find within StreamNative Cloud, and that's driven by Apache Pulsar. I want to quickly talk a little bit about the native diskless Kafka. So this is basically a part of our URSA capabilities. So let me just go there. So essentially, when we were thinking about the broader infrastructure, what we realized is that there are different stages at which the costs are incurred by the data platform. There is the networking cost, the compute and storage costs. The number one cost actually is the networking cost, because the data flows through so many different types of availability zones and deployments. So we've kind of tried to come up with a platform here, an architecture, which really lets you save costs at different stages. Whether it's like inter-availability zone data transfer, or reducing your compute for connectors, and reducing your duplicate data copies. So all this capabilities are combined in URSA, which is a part of StreamNative Cloud. And also that is actually available via both Pulsar and Kafka, depending on what is more comfortable for you as a data team. I'm going to quickly expand a little more on that. Now, I would quickly highlight that within StreamNative Cloud, you can make choices of how you want to set up your data platform. You can choose your Pulsar protocol or Kafka protocol to kind of do the interactions using either Pulsar clients or Kafka clients. But within the core platform itself, you can choose if you want to have, if you have extremely low latency requirements, or you have relaxed latency where you're okay to receive data in sub-seconds instead of receiving in milliseconds. So you can tune your platform based on these choices. And then if you want relaxed latency in sub-seconds, then you can save a lot of cost by using the diskless feature. So which means that diskless will not have things like infrastructure like Apache Bookkeeper. Essentially, as you stream data, it will go directly to an object storage, and it'll store in sort of the open table formats like Delta Lake, Iceberg, and other capabilities. If you want to choose ultra low latency, then we will have basically our disk-based infrastructure for storage. And then you can still use the other capabilities like open table formats and lakehouse storage, but at least you can tune your platform based on your choices, right? And then go from there. So that's a little bit about that. I'll keep moving in the interest of time on these features. Now, I want to highlight one more important capability, which is very whole strategic importance within StreamNative Cloud. We have built a lot of native capabilities to integrate with Databricks, Snowflake, and other services like Amazon S3 tables. Essentially, I think this is based on the diskless architecture where StreamNative can be configured to stream topics as tables in open table formats. So you can write all your topics. You basically create a cluster. You configure that to automatically choose which catalog you want to write to, which type of backend destination you want to write to. And then it'll start streaming all your topics as iceberg tables or delta tables. And then you can query all of them from your favorite third-party SQL tools. right? Or you can query them from Databricks or Snowflake, right? So this is one of the important features which we continue to improve. I'm happy to share more details about it as we go along. So Lakehouse integration, something for you to remember. And then lastly, I want to touch upon this new capability which we recently launched called the Orca Agent Engine. Now, Orca is basically a capability within StreamNative Cloud, which allows you to write agents using any of the kits like OpenAI Kit or Google ADK Kit and deploy that within StreamNative Cloud infrastructure. The beauty of agents, as you all know, is that it makes it easier for you to run long-running processes instead of just a request and response style, a chat style of interaction, which lets you learn about your clusters, learn about the data in your platform. This agent can do many things, all depending on what set of logic you want to run. It can become your long-time running application, which has access to your data and can perform based on a custom logic, and it's always running, right? So this is, think about like stream processing, which is on steroids, and much more than that, using some of the new technologies like, agentic AI, which now you can use to build cool applications for real-time data, right? So that's a little bit about StreamNative Cloud and some of the capabilities. And then I'm happy to take some questions at the end. But in the interest of time, I'm going to pass on to Rafał, who's going to cover the real part of the session about this customer profile and what sort of setup this customer had as they were building up this data platform related to the vehicle data profiles. So with that, I'm going to pass on to Rafał. Rafał, over to you.
Thank you, Kundan. After presenting the system requirements and the platform that we decided to use, we can move
Rafał,
to discuss them.
We can't hear you.
Can you hear me?
Yeah, I can hear you. I can hear Rafał and Łukasz.
Okay.
Okay. So we can now show the proposed system. We decided to create a system based on the incremental implementation. The first events we considered had two basic characteristics. They need to serve as the basis for other system and enable us to verify end-to-end our assumptions. The first event we decided to implement was the vehicle creation event, because it's the event where the vehicle has a VIN number assigned. And of course, for this event, we need to implement different types of components. For example, source system. In this case, it was IBM MQ. And reader for this source system that put the data to the input topic on the Pulsar. And then, of course, we needed to prepare all type of Pulsar entities, such as namespaces, topics, schemas, etc. And the Flink job itself that do the heavy lifting by doing all kind of asynchronous enrichment for the incoming data. And at the end, we also needed to prepare a sink that sends data from the output topic to the Elasticsearch in this case. Okay, with this in mind, let's move on to demonstrate how the individual components of the system that we are developing relate to one another. Here we have the diagram that shows how these individual components work together, of course, in the schematic way, very general. On the left, we see different kinds of external systems from which input data originates, whether it's an active MQ queue, Kafka topics, and S3 bucket, or any other system. We need to be able to retrieve the data from these sources and input them into our system. There are different cases that need a different approach. For example, Apache Pulsar provides numerous built-in connectors that allow us to connect to various source systems. Among them, there are connectors for Kafka, RabbitMQ, Cassandra, etc. And we also see that there are input sources that doesn't have an existing consumer. So we have also to address somehow this case. And in this case, we can implement an application that connects to the source system and sends events to our system. And also there are cases where there is no data available at some kind of storage, but we need to pull the data ourselves. This, for example, is a case for the RESTful API that we need to create an application that makes calls to this API and put data into our system. Next, in the center of the diagram, we see the essence of the streaming system, Pulsar function and Flink jobs, which are responsible for processing events, transforming and enriching them, and implementing functional business requirements. This is the core part of the system. And of course, when we process the data, the events need to be sent to output topics, and from the output topics, they are needed to be prepared in a way that outside so-called downstream system will be able to get this data for their purpose. And of course, there are components that logs their activities, and all of these logs are put on a Pulsar topic, and from the Pulsar topic they are sent to the Datadog for further inspection. I will talk a bit about this later. Next, after discussing the application architecture, for an example event type, we can take a comprehensive look at the event flow with particular emphasis on various data sources and their intended destinations. Events can originate between factories and car repair shops. Another data type source is so-called connected cars, meaning all events generated by car itself while a driver is using the car. Other data sources include all activities related to customer service and marketing. And of course, we also have different types of cars lifecycle events, such as battery check or engine check. Then, of course, the events or the data is processed, and after processing events, they are delivered to the data consumers, and the specific type of a consumer system are analytical tools that play special role among the consumers, allowing them to extract added value from the input data. Furthermore, as we mentioned, data is stored in a way that allows for easy retrieval of the data that is currently needed. And now let's talk a bit about the benefits from the architecture. By combining Pulsar with Flink, we gain a powerful tool for processing large amounts of data in a short time. Pulsar enables effortless partitioning of input topics, allowing us to increase throughput without requiring changes to the system implementation. Similarly, Flink allows us to change the level of parallelism, allowing to increase throughput and reduce latency as the amount of input data increases. For now, we handle around 200,000 events per day. It's not maybe that big in comparison with other systems, but keep in mind that we need to do serious enrichment of this data, including calling an external API. Of course, this also includes validation of the events, checking the correct order of events, and ensuring that all data required to process a given event is present. If data is missing, the events are sent to for recycling and waiting for the data to be present in the future. In many business cases, as Łukasz mentioned at the beginning, it is important that no events are lost. In the case of a system failure, to avoid losing events, Flink provides exactly one semantics, meaning the framework guarantees that each event will be processed eventually exactly one time, no less, no more. This needs to be exactly one. In the event of the failure, once the system recovers, the system resumes processing events from the point where the failure occurred. The exactly one semantic is supported as the system scales. Of course, that's the requirement that the Flink and Pulsar together provide us. Among the requirements, as we also mentioned, we need to make sure that downstream system can access the data in a way that ensures seamless integration. As mentioned previously, the goal is achieved through a rich library of various connectors that are present. And in a case where such connector is not present, we are able to quite easily implement it ourselves. And the next important thing is to be able to see what is going on in the system, and for this, the multiple different kind of metrics are present both from Pulsar and Flink, and we obtain them and store them in Datadog and other monitoring tools. And now I will pass the microphone to Łukasz, who will describe the key takeaways from the presentation. Thank you.
Thank you, Rafał, for your part. I hope that you can hear me.
Yes.
Okay. So as we are reaching the end of our presentation, let's sum it up. The project was a base, foundations, providing platform for aggregation of data, correlation of events from multiple sources. Right now it's being expanded by next lifecycle related and of course in-car telemetry related events. And due to the data lineage and auditability, it is extremely useful in the context of, for example, insurance, warranty, and compliance, for example, GDPR, WLTP, and other certifications. It's a real enabler for predictive analysis because it's based on the significant history of events coming from millions of vehicles. And ultimately, architecture is ready for the integration with AI, what Kundan mentioned. AI is or rather was usually looking into the past based on the historical data. But AI models can consume events on fly, be supplied with the recent, almost real-time data. So less latency in advanced data analysis, and system may learn autonomously without relying on the new human prompts and inputs. And we have a couple of guests here. Maybe some of you might be thinking, okay, but I'm not in the automotive or fleet management domain. But that's perfectly fine, because what you see here is just the example domain, as even Kundan mentioned a number of domains. The architecture, so data producers, consumers, governance, and storage layers, everything is universal. It is built on the same principles and technologies. So, for example, Pulsar for streaming and messaging, and Flink for data processing. So the same architecture can be easily applied to finance, insurance, IoT, or logistics. And let's see how it looks in another industry. So, for example, this logistics and delivery. This is the same picture, but instead of car factories, we have the warehouse, so package registration, package loading, etc. Instead of cars, we have the delivery vehicles domain. So tracking the route of the delivery vehicles. So it means tracking the route of single packages. We have the customer apps generating data related to placing the orders, rescheduling deliveries, etc. So all the data flows through the same process layer, Pulsar and Flink, ensuring the data consistency. What's different? Of course, the consuming systems specific for the industry and the use case. So with this short example, I want to to finish the main part of the presentation. And right now we can move to the Q&A session, because I see that we have a couple of questions. How did you address the challenge of scalability in terms of handling an increased number of data sources? Rafał, I think it's you.
Okay, sure. I think we talked a bit about that in the presentation, but I think the key feature that needs to be present in the system is a horizontal scalable architecture. Pulsar allowed us to flexibly add new partition and brokers when they were needed to a topic and to the Pulsar platform itself. And that ensured us that when the amount of data increases, we were able to not let go the performance of the system, throughput and latency. And for Flink, I think the key feature is to be able to quickly change the parallelism level of the different operators in the Flink job. Yeah, so I would say that there are two main points that allows us to be able to easily scale the system when needed.
Okay, as we don't have the direct interaction with the guests, then let's jump to another question. What does the roadmap for catalog integration look like for StreamNative Cloud? I think, Kundan, it's for you.
Sounds good. Thank you, Łukasz. Yes, absolutely. So the roadmap for the catalog integration definitely looks exciting. We are basically keeping an eye on how the industry is adopting all the open table formats and all the work which is going on in the catalog space. As you all know, basically Databricks announced a lot of capabilities during Data and AI Summit. So we've, which is around unifying basically Iceberg and Delta Lake type of support within Unity Catalog. So we already launched a lot of native integrations related to that. But I think some of the new things which are coming up are for the folks who are familiar with the space, the Apache Iceberg v3 support. That's going to offer a lot of interesting features, like particularly the row-based lineage you can track. So for example, like I'm just making a simple example. Somebody places an order, or like somebody adds a order to the shopping cart and then goes and modifies it. You know, these are generating two different events, right? And then, you know, basically there are ways in which you can track upserts and then all the way end to end from StreamNative platform to Databricks and see that in the lineage UI. So a lot of interesting use cases around Iceberg v3. Also quickly to add, we're also working closely with companies like Snowflake. They have their Horizon catalog, a lot of governance capabilities there. So I think that's something we can expect to hear from us. So those are the two important ones, I would say. But we're happy to keep sharing more as and when we are announcing that. We usually create a blog and do a webcast with that corresponding ISV like Databricks or Snowflake when this happens, when we launch new features. So keep a lookout for that, and we will be sharing a lot more on that. Yeah. I hope I answered the question. Yeah.
And I think next question to you as well, related to StreamNative customers' references?
Yeah, absolutely. I think there are quite a few. In fact, I'd like to share, let me share a link. And the perfect place to share the link here, let me see, it'll be, I can just post it in the public channel, right? Yeah, there you go. So here I'm going to type something. Here's the link to all the customer reference, customer success stories of StreamNative Cloud and Pulsar. Okay, so I'm putting a link there. Hopefully, you can see Łukasz. If you can please confirm, that'll be helpful. And then actually,
yeah. So I think everyone can see it.
You see that? Okay, I put it in the public tab. And then I think I will also like to share one more thing. It's not related to references, but something which you'll find helpful. We recently had a data streaming summit in San Francisco. It was an in-person event, and a lot of good sessions were organized there by StreamNative. It's an open event for all type of streaming technologies, not just Pulsar, not just Kafka, others too. So I'm sharing a link here because we now have the recordings available for you to go and see. Anybody can watch it actually. So I'm putting this link here, and then you will find a link to the watch recordings tab. A lot of interesting sessions from OpenAI, and there's Snowflake and Databricks. So hope you can find them helpful. So that's why I'm sharing. Yeah.
Okay, thank you, Kundan. What lessons from this implementation can be applied when building future systems? So, as I was mentioning, the key takeaways, I think that one of the key lessons is that it's crucial to think about the data strategy as early as possible, ideally already in the planning phase. So you need to clearly define what data you need, what purpose it will serve, how long it should be stored, and what the expected real time actually means. Because establishing these principles upfront helps to design a more efficient data architecture, most probably avoid unnecessary complexity later, and ensure that system delivers the business value rather than just collecting data for its own sake. I hope that this one of the, let's say, key lessons learned is enough to share right now. Okay, do we have any other questions? I'm watching, trying to go through the chat. If we have any more. Okay, I see on a chat here about the financial arguments to talk to the board. I'm smiling because it is a very relevant question, which in fact could be asked to our customer. But just an example, in this case, by connecting real-time vehicle events, we can trigger more coordinated and timely service actions for end users. For example, if tire wear or another maintenance indicator appears in the application, the system can immediately suggest service appointment slot and direct the customer to the OEM's original authorized workshop rather to the third-party garages. So of course it improves the customer's retention and increases the after-sales revenue for the OEM. So helps the OEM to capture the value, which would most probably lead to the independent service market. So this is one of the examples that quickly comes to my mind. Do we have any other questions? If we see any other, then we may jump to it. Otherwise, let me jump to the final slide. So, of course, please follow us, our social media profiles for updates on upcoming events, webinars. You will find all of the information there. Plus, Kundan also posted the link to the events organized by the StreamNative. And of course, please visit our website. Here you have the QR code to scan and directly enter the website. So maybe to sum up, if you deal with high volume data from multiple sources, you have the issues with data quality or legacy systems with bottlenecks, you have the data spread across systems, let us know. For sure, we will jointly with StreamNative support you to deep dive into your specific use case. And right now the short survey, if you want, please take a part and click. And of course, thank you for participation in the webinar. As I mentioned, we will share the recording and all the materials and link quickly after the webinar with all of you. And if we do not have any other questions, and I don't see, thank you all. So Kundan and Rafał, thank you for the participation in this.
Thank you very much.
Thanks a lot, Łukasz. Yeah.
Okay, so please have a good afternoon, and in your case, Kundan, good morning still. See.
Absolutely. Have a good day.
Thank you. Goodbye for everyone.
Thank you. Goodbye.